Hello there and welcome to this new section of the course. In the previous section, so throughout the lectures of the previous section, I covered how to set up Python on your computer and also the Atom editor, and also showed you how to create a Python program, which is this one in here that we created. So at this point you should have an editor and you should know how to create a Python file and write some code in it, like this one in here. Now, in this new section, what I'll cover is variables and data types. So in the next lecture, you will be able to create and understand variables. And in the lectures after that, you're going to learn about the various data types that we use in Python. So in this video, I just wanted to introduce you to this new section. And let's go to the next video where I explain variables. See you. Hi, in this lecture, you're going to learn about variables. So what is a variable? Well, a variable is like a container where you can store various data types in Python. For instance, this program now, this doesn't have any variable in it for now. So let me try and execute it. And you'll see that this prints out the hello string. String is a data type, but we'll cover that later. Now, what is a variable? Well, variables will keep your code more organized. Let me create a variable here, greeting. So you can call your variables whatever you like. You can give them any name. However, there are some naming rules which I'll mention in just a bit. So let me create this variable for now. I'll store in this variable, I said variables are like containers, so I'll store this text in the variable greeting. And then what I do is, instead of doing print hello, I'll do print greeting. And save the script, Ctrl S, and then go to the command line, the upper arrow key, enter to execute, and you get the same output. So this is how you create a variable. You don't use any quotes, because when you use quotes, you are creating a string data type, not a variable. And you can also use a dash before the variable. That would also be fine. So you get the output correctly, but you cannot use numbers before the variable. So Ctrl S to save, execute, and you get an invalid syntax. So this syntax is not valid in Python. But you can use numbers after or between the variable name. Let's say here greeting 2. So that would be fine to use. So that's the condition about naming your variables. You can start them with a letter or an underscore. Now, if you're not experienced with programming, you may still be confused on why do we use these variables. Well, this is a very simple program, actually very useless, but normally your programs will interact with users. That is what we call a real program. You create a program to give it to people so they can interact with the program, they can generate all different outputs and so on. So let's go ahead and make this program more dynamic. So what I'll do here is I'll get the text from the user interactively. To do that, you need to use the input function. This is also a Python function. Inside the function, you can enter a message to the user. So let's say write a greeting, a colon, and make some space there, and then you print greeting 2. Yeah, save the script, execute, and now the program is asking us to enter some input. So let's go ahead and say hi this time, and we get the output printed out in here. Hi. So what happened here is we created a variable, and that variable will store the value that the user submits in the command line here in the terminal. So the user submitted the hi text, and this text will be stored in this variable. So as I said, variables are like containers. And then you can use this text in various ways. But in this scenario, I'm just passing it to the print function, so I want to print it out on the terminal here. And the print function will get the value that is stored in the greeting2 variable and will print it out on the terminal. That's it. And yeah, I'd like to close this lecture now, and I'll see you in the next lecture. Great. Now let's learn numbers. Let me open an interactive shell here to explain this faster. And so, numbers, you know what numbers are. To create a number, you just type the number in Python, and that's it. And you also have operators, like this is the plus operator. And you can also store numbers in variables. Let's say a equals to 2, b equals to 3, and then if you do a plus b, you get 5. Something to note is that, if you do that in here, a equals to 2, b equals to 3, and then if you just do a plus b, and then you execute the script. Let me open another terminal. You'll not get any output in there. The reason is that you are not printing out anything in your program. So this is different from an interactive session. Here, if you simply do an operation, or if you simply call a variable like that, you'll get the output promptly. So this is just for simplicity when you're trying things out, so you don't have to pass print explicitly, but Python will understand that you meant print. But here things are more strict, so if you want to print out the output, you want to say print a plus b, and then execute, and you get the output. And yeah, basically that's the only difference between executing a program from a Python file and running the code in the interactive shell. So these are numbers, and I can prove that if I do type 2, for instance, you'll see that this is an int type, which means is an integer. So basically we have integers and we have floats. These are the two main types of numbers. A float is, let's say 2.4, it's a float, and I can prove that. 2.4, type 2.4, you'll see that this is a float. However, if you do type 2 in brackets, you'll see that this is a string, it's not a number, and therefore you cannot make operations using a string and a number. So Python will give you a type error, and this is saying cannot convert integer to string implicitly. So when you do a string plus something else, Python expects that you were adding another string after a plus sign, so that's why it says I cannot convert integer object, so you cannot convert this to a string implicitly. Because if you were to do 2 plus 3, you'd get 23, because Python treats these two as text. So to understand it better, let's add some text here, b, so you get 2a 3b. So it's a concatenation operation. When the plus operator is used with strings, it is referred to as concatenation. Now let's go back to our sample program that we used earlier, which was this one in here. So now what if instead of getting a greeting from the user, you ask them for their age? Enter your age. So this is just a message, you can write anything you want there, but just try to have a message that makes some sense to the user. And so also I'm going to change the variable name to something more meaningful, age, and then what I want to do is, let's say new age, I want to calculate their age plus 50. Why not? And then print out the new age. Save the script, and let's go and execute this. We are going to get an error here, I warn you, but it's good that you see the errors that we get, because that's how you learn better. So Python my program execute. For now it's working fine, because what happens is Python executes a script line by line. So it goes to the first line, and if there is no error, it executes that line. And in this case we have an input function, so the program is on standby mode, so it expects from the user to enter the input. And so let's enter the input here, let's say 28, and here is the error that we get. So again, you saw this error before. This is saying type error cannot convert int object to string implicitly. And you also have the line here that the error occurred. So these are important messages. And line 2 in here. So what's happening is that age is a string, it's not a number. Therefore Python cannot add up a string with a number. And so why is age a string? Because that's what the input function produces. So the input function gets the user input and converts it to a string. So even if you pass a number there, this will always convert the everything to a string. Therefore Python, cannot concatenate 28 plus 50. So what can you do in that case? Well, you want to convert that string into an integer, and for that you want to use the int function. So it's a Python function that does the work. As you can see, it outputs now the correct output. So 28 plus 50 equals to 78. And similarly, you can convert numbers to strings. Let's say str50, and I think you will get an error here. Yep, it says type error, unsupported operand type for plus. So you're adding up an integer with a string. So integer with a string. If you like to convert this to a float, let me remove that. Save, execute, 28, you get 78.0. Because what Python does when you use float is, float 28, it converts it to 28.0. So floats can be useful in certain scenario, and you'll have a lot of scenario in the course. So don't worry about that now, because we have real world applications later on where you see the real benefit of everything that we are explaining here in these early sections that cover the basics. So this is about numbers. Try to practice them a little bit, and I'll talk to you in the next lecture. Hi again, in this lecture I'll show you how to do math operations with numbers. So we're going to look at math operators. Let's go straight away and open a Python session, and let me write a math expression there. 20 minus 10 divided by 5 times 3 in the power of 2. And what we get is 2.0. So why did I write this long expression? Well, because I want to explain to you the order of operators. So when you have multiple operators in an expression, the one to be executed first is the exponent. So we have 3 in power of 2 here, and that will give us 9. So power is the first to be executed, and after that is division and multiplication. Actually, division and multiplication are on the same level when talking about order, but the one that is first will be executed first. So in this case, division is the first one. So what will happen here is Python will ignore minus for now, so it will divide 10 by 5 and it will give 2, and then it will do 2 times 9. So again, 10 divided by 5, 2 times 9, 19. And then we have the rest of the operators, which could be a plus or minus. So in this case we have minus, and so 20 minus 18, we have 2.0. And so you'd ask why we have 2.0, because 10 divided by 5 gives 2.0. So division outputs a float in Python 3. If you are on Python 2, it would output an integer. Now, to make your expressions look better, you'd want to remove the spaces for the power operator, and also you do like that. So now you can read it better. So 2 times 9 and then 20 minus 18 and so on. You get the idea. You get 2.0 again. And now if you want to execute the minus operator first, you'd want to put that inside brackets. So why did we get 18? Well, because 20 minus 10 gives 10, and then 10 divided by 5 gives 2, and then 2 times 9 gives 18. That's the idea. And then you could also do this, put these in brackets, and what would happen here is, 10 here, 15 here, in the power of 2, so 15 in the power of 2, and then 10, so 10 divided by 15 in the power of 2. Let's see what we get. Yeah, we got that. So let's see if I was right. 15 in the power of 2, we get 225, and then we got 10 on the other side, so 10 divided by 225, we get that number. So whenever you want to change the order of operators, you should use brackets. So yeah, I hope you get the idea, and please try this out. So try to do a few operations with numbers to get used to it. And yeah, I'll talk to you later. Thanks. Hi, welcome again. In the previous lecture we were talking about numbers. Specifically, we looked at integers and float data types. So these are referred to as data types in Python. So integers and floats. In this lecture we're going to look at strings. I already mentioned strings in the previous lecture. So a string is everything that goes inside quotes. Hi there, that is a string. And of course strings can be stored in variables. And you can print those variables. So we're using the interactive shell now, but of course you can use a Python script as we did previously. So numbers were used to do math operations, but strings are used for displaying information for the user. So let's say you have a web application and you want to generate some text dynamically on the web page. So you would use Python on the backend, and Python would send strings to the HTML code, and HTML would render the code on the web page. Basically, that's the idea. Or if you want to create a notepad, an editor with Python, such as Atom, let's say, all these things you see here, so my program.py, selection, find, all these would be written as strings inside Python. And then you display them on the interface using various functions. For instance, if you want to display a string on the terminal, you'd use the print function. Now strings have methods associated with them. What I mean with methods is, let me go ahead and try out a method. For methods you need to use a dot notation. So you refer to the string, which is string C in our case, actually variable C, but the variable is holding the strings, so it's the same as doing here dot. So let's do C dot replace, and what I want to replace is E with I. So I'm replacing, for string here, I'm replacing letter E with letter I. And what that will do, it will replace all the letters, all the occurrences of this letter in the string. So you'd ask, where can we see these methods? Well, that's very easy actually. You can do dir and then pass a string there, any string. It could be C, it could be an empty string or whatever. And that will print out all the available methods that you can use with strings. So let's say C.upper, that will convert the string to uppercase letters. Now, if you want to know what these methods are about, you could ask for help. Just do help, and then C, so the string, or just empty string dot replace, just like that. And here you get the help. And so you get the definition here, replace method of the string instance. So string is like the blueprint that creates strings objects. Or you can say the data type that represents text. Look here, here is the syntax. So what you do is you use the string like we did. So let's say here, replace, then you open brackets, here is the old item you want to remove from the string, and then the new item, we want to replace it with I, and then what you see here in square brackets, that means this parameter is optional, so you can either pass it or not. In the previous case we didn't pass it, so what Python did was it replaced all the occurrences of the E item. But if you want to replace only the first occurrence, you do one there, and that will replace only the first E with I. That's how it works. So strings, they support functions, so print is a function here, and they support methods like this one here, and they also support operators. So you can do here plus there, and you get here there. Or you can make it more readable like that. So an empty space is also a string. And yeah, that's about strings for now, and I'll talk to you later. Hi again. In the previous lecture we talked about strings, and in this lecture again we are going deeper into learning strings. Specifically we're going to look at indexing. Indexing is a very important concept, not only with strings but with other data types that we'll be looking at later, such as lists and tuples and dictionaries. So please follow this lecture. And yeah, let's talk about indexing. Let me open a Python interactive session. And let me create a string. Hi there, exclamation mark, and close quote. Now, when you create a string, every string that you create, Python under the hood, what it does is it assigns a number to each of the items of your string. So it starts from 0, so age will be assigned an index of 0, and then a 1 for I, 2 for the white space, 3 for T, 4, 5, 6, 7, 8. So the exclamation mark character will have an index of 8. So you would ask, why is this useful? Well, this allows you to extract certain parts from a string. And there is a certain notation to do that. You'd want to access the string, so in this case that's the variable C holding the string. And then you want to use square brackets. So an opening square bracket and then a closing square bracket, and inside those square brackets you pass the index of the item that you want to extract. Let's say I want the T character, so that would be 0, 1, 2, 3. I pass number 3 there as an index, and that will extract for me letter T, which is actually a string. So you can check the type of the output, and you'll see that that's a string. So a string is made of strings, you can say so. If you wanted age, you'd pass 0, and if you wanted the last character, Well, you might have to count, so 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I'm including type there. Sorry about that. So C8 would give you the exclamation mark. But there's also another indexing system there that Python uses. So in this case we had to count from the beginning to the end of the string, but wouldn't it be useful if you had another system that lets you count from the end, so from right to left? Well, such a system exists and it starts from -1, so the exclamation mark would be -1. And yeah, that you can extract that with that. -2 would be E, R would be -3, and so on up to age. So you have two indexing systems there, which allow you to extract items depending on whether the items are in the beginning or near the end. Now, what if you want to extract more than one item from a string? Let's say you want to extract high. Well, there is a notation for that too. And so high is expanding from index 0 to index 1, so up to here. So let's try 0 to 1. That will not work very good, but let's see. So as I said, this will return only age, so it doesn't return item with index 1, and that's because splitting in Python, so we're splitting a string here. Splitting in Python is upper bound exclusive, which means that the upper bound of the split here is not included in the output. So if you want to include I, you'd want to pass the index after I, which is 2. So this is a string just for reference, and so we extracted item with index 0 and item with index 1, and then the split starts right there at index 2, so it doesn't include the space, just high. If you pass 3 there, that would include the white space as well. And similarly you can pass like 1, and that will include I and the space. There are also shortcuts, so if you pass 0 to, like nothing to 3, that is the same as doing 0 to 3. So it will include 0, 1 and 2. And similarly, if you want to extract there with the exclamation mark, well, what you'd want to do is T would have an index of 0, 1, 2, 3, so 3, and then you can just pass a column there and execute it, and that will give you there with the exclamation mark. And let's now try to extract R and E using negative indexing. So something to know is that even though we are using negative indexing, which starts from right to left, the splitting will work from left to right, which means the first index you want to pass is that of the first item, so R. We pass -3 for R, because you know we have -1, -2 and -3. So -3 for R, and then we want E, which is -2, but since splitting is upper bound exclusive, we want to pass -1 there. So let's try that, -1, execute, and yeah, we get the correct output. That's the idea. If you didn't pass anything here, you'd get the exclamation mark as well. So it will take a while until you get used to this, but with some practice you'll be able to remember these notations. And yeah, that's what I wanted to cover in this lecture. So this was about string indexing and splitting. So you split using the index that Python uses on the background. And yeah, I hope you enjoy this, and I'll talk to you later. Thanks. Great, now let's look at lists. So in the previous lecture we were looking at strings and indexing and splitting strings, and now we'll be working with lists, which are very similar to strings. They are similar because they are both referred to as sequences. So they are sequences of items. The difference is that, let me open Python. So the difference is that a string is made of other strings, so it can contain only strings, so characters or strings, whatever you like to call it. However, lists can contain various other data types, let's say age, a letter, a number, and also a string. So this is a string, the first one. This is a number, an integer. This is also a string with multiple characters. And that is a list. So for lists, you want to use square brackets to create a list. Execute. And yeah, you can call it. And so this is a list of 3 items. And you can also store other objects in a list, but we'll cover other objects in later sections. You know, we have table objects with lots of data. You may store files in a list. You may store widgets of a graphical user interface that you are building, and so on. So lists are very useful. And lists also have indexing, and you can split lists, you can extract items, and so on. So the good news is that lists have the same indexing system as strings. So you learned that in the previous lecture, and you can go ahead and apply that system now. So let's extract number 2. That would have an index of 1. Execute that, and yeah, you get 2 there. If you check the type, you'll see that's an integer. So every item of a list has its own data type. You can also access more than one item of a list. Let's say you want the first 2 items. You do 0, 1, 2. So like that, or 0 to 2, whatever you like. And that will produce another list. So the type of this split is a list. The type of the split of a string is a string. So S for the string here, C for the list. Lists now have methods associated with them, just like strings do, and so you can check what methods you have available there by just doing dir list. So list is the blueprint. You can use list, you can pass empty square brackets in there. It's the same thing. And then you can use help to look at each of these methods. So these are the methods without the underscore. And let's look at the append method. So to apply a method, you do C, the dot notation, append, and here I'll add 3. Well, what that does is it adds another item to the end of the list. So it appends an item to the list. And you can explore the other methods if you like. So let's say help, remove, like that. And you'll see how to use that remove method. So you do C remove, and then you pass the value of the item that you want to remove. So not the index, but the value. Let's say we want to remove 2, and you see that 2 is now gone from the list. So yeah, look at the other methods of the list and try to experiment with lists and play around with them, access items and split them, and you'll be good to go then. Yeah, thanks. I'll talk to you later. Let's now look at tuples. In the previous lecture we looked at lists, and tuples are very similar to lists. The only difference is that tuples are not mutable, so you cannot change a tuple. Lists are used much more than tuples, so tuples are only used in very specific scenario. We will see some scenarios throughout the course when we build the real-world applications. So you don't have to worry about understanding when to use a tuple in programming for now. Anyway, I want to show you the syntax. So you can create a tuple like that. So a tuple, just like lists, they may contain different data types. Let's say 3, 4, and so on. Oh, sorry, I was writing in the terminal. Let me open the Python shell. So again, you have strings, numbers, and floats, if you like, whatever type that you want. You can pass in a tuple and in a list. And of course, you can use indexing for tuples as well. So let's access the last item, and that will give 4.6. The difference is that, you know, tuples, they have some slight different methods than lists. So if you do dir list, you'll see that lists have much more methods available than tuples. So for instance, you can append items to a list, you can clear the list and copy and count. Count is available for tuples because count doesn't change the data type, so it doesn't change the tuple, it just counts how many items are there in a tuple. As I said, tuples are immutable, so you cannot change them. That's why these methods that change the data type, like inserting new values and popping out values, removing values, reversing and sorting, so these are not available. And yeah, this is more or less about tuples. In case you need them later, they are there for you. Hope you're enjoying the course, and I'll talk to you later. Hey, hello! Let's look at dictionaries in this lecture. This far we looked at strings, we looked at lists and tuples, and so now we have yet another data type, and these are dictionaries. Let me open the Python shell, and let me create a list first. I'm just creating this for a reference, so to compare lists with dictionaries, but you don't need to create a list for creating a dictionary. So to create a dictionary, you need curly brackets. So an open and a closing curly bracket. And then inside that, you'd pass the items of the dictionary. Now the difference here with dictionaries is that instead of letting Python add default indexes for your items, you want to create those indexes yourself explicitly. So therefore, for dictionaries, you do something like this: name, a colon, and then the item. Let me write another one: surname, colon, and then the other item. And yeah, that's it. That's a dictionary. So what we have here is, when I was talking about indexing, I was referring to these things. Actually, these two are referred to as keys, not indexes. So for dictionaries, you can create custom indexes, so to say. And so these are keys. So we have key and value. Key and value. This is good because now if you want to access one of the values of the dictionary, again, you'd use square brackets, just as you did with strings, lists, and tuples, and then there you pass the key, which value you want to extract. So if you want to extract John, you want to pass the key of John, and that will extract the John value. Something to note is that dictionaries are an unordered collection of items. So sometimes you may notice that the order of the key and values is not maintained. So you may see that surname has gone the first place. So surname Smith, the pair has gone the first one, and name John is the second one, and so on. So this is different from lists and strings and tuples. And the reason Python doesn't keep the order is that, you know, the way you access dictionaries is you explicitly pass the key of the dictionary when you access it, and so you don't need to know the order of the dictionary. Whenever you want to access something, you say surname, for instance, and that will return Smith, no matter where Smith is, so whether it is the first one, second, or and so on. And interestingly, in dictionaries you can also pass you can have like lists as values, or even tuples. So let me write a tuple there, or let me keep it like that, and let me add another key and pair here. Let's say cities, Let's say John Smith lived in 3 cities: Porto and San Diego and Bali. You close a bracket there. So as you see, we have the key here, we have the colon, and then you have the value, which can be anything. So it can be a string, it can be a number, it can be a list, a tuple. In this case, that's a tuple. So if you access now cities like that, you'd get, sorry, I had 2 brackets there. So you would get the tuple. And then you can also do tricks like, you know, if you want to access Bali, you'd add other brackets there and pass 2, and that will return Bali. So why is that? That's because, you know, up to here you have a tuple. That's a tuple object, and then from that tuple you use again the square brackets notation to access an item from that tuple. So you want item with index 2, and that is Bali. And yeah, that's about dictionaries. Try them out some more, play around, and you will be able to comfortably create and access items from a dictionary. So hope you're enjoying this, and talk to you later.